Hey everyone, and welcome to another deep dive. Today we're taking a look at some of the most puzzling places in space, those spots in the cosmos that really make scientists scratch their heads.
Yeah, it's amazing. With all the advances we've made in astronomy, there's still these big mysteries out there just waiting to be solved.
Absolutely. And for this deep dive, our guide is Unexplained Mysteries of the Universe. So let's jump right in, and we'll start with something that's almost impossible to wrap your head around. The Boötes Void. Picture a region of space so incredibly empty that it could hold thousands of galaxies, like our own Milky Way.
Yeah, you're talking about a region that spans 330 million light years across, and it's mostly empty space. Now, we know that voids do form naturally, as galaxies cluster together. But the Boötes void is so much larger than what we'd expect to see based on our current understanding of how galaxies evolve.
So it's like a cosmic ghost town. But it's not completely empty, is it?
Okay.
There are a few galaxies scattered within the void, right?
Right. There are a handful of galaxies in there, and it's kind of eerie to think about them being so isolated in this vast expanse of nothingness.
Yeah, like lonely ships in a dark ocean.
Exactly. And that's what fuels all sorts of speculation about what might have happened there. Some theories suggest it could be the aftermath of some incredibly powerful event that ripped apart galaxies in that region. A cosmic demolition derby.
Wow, that's intense. But there are other theories too, right? Ones that are even a bit more out there.
Well, there's always the idea of an advanced civilization shaping the void, manipulating matter and energy on a scale that's just mind-boggling to us.
Okay, an advanced civilization. Really? That sounds like something straight out of science fiction.
Yeah.
What would that even look like, and how could they possibly create a void on that scale?
Well, those are the million-dollar questions, aren't they? And honestly, we just don't have the answers yet. But the fact that we're even considering such possibilities shows just how much the Buddhist void challenges our current understanding of the universe.
It really forces us to think outside the box, doesn't it? But let's move on to another mystery. This time, it's not about a place that's empty, but about a force we can't even see, but that's pulling our galaxy and countless others towards it. We're talking about the Great Attractor, and it's one of the biggest enigmas in astronomy.
It's like an invisible hand guiding the cosmic dance of galaxies. The Great Attractor lies within what we call the zone of avoidance, a region of space that's obscured by dust clouds in our own Milky Way. So we can't directly observe it, but we can see its effects on the motion of galaxies.
So we're being pulled towards something at like 600 kilometers per second, and we don't even know what it is. That's both fascinating and a little scary.
Yeah, it's a bit unsettling, isn't it? The leading theories point to a massive concentration of matter, maybe a supercluster of galaxies, or perhaps it's the influence of dark matter, that mysterious stuff that makes up a huge chunk of the universe's mass.
But there's also the possibility that it's something completely unknown to science, right?
Absolutely. We could be dealing with something entirely new, something that will force us to rewrite the textbooks, and that's what makes cosmology so exciting.
It's the thrill of the unknown. Now, speaking of the unknown, let's talk about a mystery that might hint at other universes. The cosmic microwave background cold spot.
Ah, yes, the CMB cold spot. It's like a blemish on the universe's baby picture. You see, the cosmic microwave background, or CMB for short, is this faint radiation left over from the Big Bang. It's like a snapshot of the universe when it was just a fraction of a second old.
Wow, a cosmic time capsule.
Mhm.
So we're literally looking back billions of years into the past.
Precisely. And for the most part, the CMB is remarkably uniform, like a smooth baby's bottom. But then there's this one area that's significantly colder than it should be, the cold spot.
And one theory is that it could be a sign of another universe interacting with her own, a cosmic collision of realities.
Yeah, some scientists believe that if we live in a multiverse where our universe is just one bubble among countless others, then this cold spot could be a region where our bubble bumped into another one.
Okay, now that's mind-blowing. But are there any other explanations, ones that don't involve parallel universes?
Of course there are. One prominent theory is that the cold spot is caused by a supervoid, a region of emptiness even larger than the Boötes void. The idea is that as light travels through this vast empty region, it loses energy, and that shows up as a colder temperature in the CMB.
So we have two competing theories, each with pretty wild implications for our understanding of the universe. I guess that's what makes cosmology so captivating. Every new discovery seems to open up more questions than it answers.
Exactly. It's a journey of endless exploration. But let's shift gears for a moment and talk about a mystery that challenges our understanding of just how big structures in the universe can get. Get ready for the giant ring of galaxies.
A giant ring of galaxies. I thought space was practically infinite. Are there even limits to how big things can get out there?
Well, infinite is a tricky concept. And even in the vastness of space, there are theoretical limits based on our current understanding of cosmology. The standard model of how the universe evolved. This model puts constraints on the size of structures based on things like the age of the universe and how fast matter can clump together due to gravity. But this giant ring of galaxies seems to defy those limits. We're talking about a structure that's a mind-boggling 1.3 billion light years across.
So is it possible that our understanding of how the universe works is wrong? Could this ring be a sign that we're missing some fundamental piece of the puzzle?
That's a possibility, and it's one that scientists are actively exploring. Some researchers believe that the giant ring could be a relic from a very early phase of the universe, a structure that formed before the rules we currently understand came into play.
So it could be like a cosmic fossil, a window into the universe's ancient past.
Exactly. Now, to wrap things up for this part of our deep dive, let's talk about a mystery that goes from the incredibly large to the strangely absent vanishing stars.
Vanishing stars. What do you mean by that? Are you talking about stars exploding as supernovae or collapsing into black holes?
You're not talking about the usual ways stars die. We're talking about stars that literally disappear from the night sky, seemingly without a trace. No dramatic explosions, no signs of a black hole swallowing them up. Just gone, poof.
It sounds like something straight out of a science fiction movie. What are the leading explanations? Are astronomers just overlooking something obvious?
We can rule out the usual suspects, like dust clouds blocking our view or stars being swallowed by black holes. The way these stars vanish just doesn't fit with any known astronomical phenomena. And that's led to some really intriguing ideas, like the possibility of alien megastructures.
Wait, alien megastructures. Are we talking about Dyson spheres? Those hypothetical structures built by advanced civilizations to harness the energy of a star?
Exactly. Imagine a civilization so technologically advanced that they could build a structure completely enclosing a star, capturing all its energy output. And if such a structure existed, it would effectively make the star invisible to us.
Wow, that's pretty wild. But are scientists actually taking that idea seriously?
It's definitely a speculative concept, but given that we haven't found any conventional explanation for these vanishing stars, we have to keep an open mind.
So we've gone from giant voids to invisible forces, a cold spot that might be another universe, a ring of galaxies that's too big for our models, and now stars disappearing potentially because of alien megastructures. My brain is officially fried.
Well, I think it's safe to say we've covered some pretty mind-blowing stuff in this first part of our deep dive.
We've just scratched the surface.
Welcome back to our deep dive. Before we go any further, I thought it would be interesting to circle back to that idea of an advanced civilization shaping the Boötes Void. We touched on it earlier, but it raises a fascinating question. How would we even detect signs of such a civilization? I mean, besides just stumbling upon a giant void.
Yeah, that's a great point.
Yeah.
We've been talking about Dyson spheres and megastructures, but what other clues might they leave behind? What would we even be looking for?
Well, one approach is to think about it in terms of the Kardashev scale. That system that categorizes civilizations based on how much energy they can harness.
Oh, yeah, right? Like a Type I civilization can use all the energy of their planet. A Type II can harness the energy of their star, and so on.
Exactly. So if we're talking about a civilization that could shape a void as massive as the Boötes Void, we're probably talking about a Type III civilization, something capable of manipulating energy on a galactic scale.
That's some serious cosmic power.
Yeah.
But how would we detect that kind of energy manipulation? Would we see like giant lasers or something?
Not necessarily. It might be more subtle than that. We might look for unusual patterns in the distribution of matter, or maybe anomalies in the cosmic microwave background radiation. Things that don't fit with our current understanding of physics.
So it's not just about looking for giant structures, but also about searching for these subtle fingerprints they might leave behind on the universe itself.
Exactly. And we also have to remember that our understanding of physics and technology is constantly evolving. What might seem like magic or the work of an advanced civilization today could have a perfectly natural explanation that we just haven't figured out yet.
That's a good point. It keeps things interesting. But for now, let's go back to those vanishing stars for a second. How do astronomers even know a star has vanished? It's not like they're staring at every single star in the sky all the time, right?
You're right. They can't monitor every star continuously. A lot of the data comes from these large-scale sky surveys, where telescopes scan huge portions of the night sky over many years. And then by comparing images taken at different times, they can spot changes in star brightness and even identify stars that have seemingly disappeared.
So it's like they're looking for missing pieces in the Cosmic Soto album. Hey, that star was there before and now it's gone.
Precisely. And the thing is, it's not just a few isolated cases. There are significant significant number of stars that have been observed to vanish enough to warrant serious investigation.
Right, so before jumping to conclusions about alien megastructures, scientists have to rule out more mundane explanations.
Of course. Like maybe there's a dust cloud blocking our view, or maybe the star is undergoing some weird stellar activity that we don't fully understand yet. But what's really intriguing is that these vanishing stars don't seem to fit any of the known patterns of stellar variability or death. They just poof.
Poof, like magic.
Yeah.
Okay, so let's play devil's advocate for a moment and say that some of these vanishing stars are actually surrounded by Dyson spheres. What would that tell us about these hypothetical alien civilizations?
Well, it would mean they've mastered stellar engineering. They'd be capable of harnessing the entire energy output of a star. Think about that for a second.
Yeah.
All the energy we use on Earth in a year is just a tiny fraction of what our sun produces in a single second. A Dyson sphere would allow a civilization to capture and utilize all that energy.
Wow, that's an insane amount of power. They can probably do just about anything with that kind of energy.
Exactly. And it raises all sorts of questions about their motives and goals. Are they exploring the galaxy, colonizing new worlds, or maybe conducting experiments on a scale we can't even imagine?
It makes you wonder if we're even looking for the right signs of extraterrestrial intelligence. Maybe our current methods are too limited, too focused on finding civilizations that are similar to our own.
That's a really important point. We might be completely missing other forms of intelligence or technology that operate on principles we haven't even considered.
So even if these vanishing stars turn out to have a natural explanation, the fact that we're even entertaining these possibilities shows how much our thinking has evolved. We're willing to push the boundaries of our imagination.
Absolutely. And it's good to remember that the history of science is full of ideas that were once considered crazy but turned out to be true. So while we should always be skeptical and rigorous in our scientific inquiry, we should also keep an open mind to the unexpected. Now, to bring things back down to Earth for a bit, let's revisit those other mysteries we were talking about earlier, the Boötes Void, the Great Attractor, and the CMB cold spot. Do you think there could be any connections between these phenomena, or are they completely unrelated?
That's a good question. On the surface, they seem like separate puzzles. But I guess it's possible that there are underlying connections we haven't discovered yet.
Exactly. For instance, some theories suggest that the distribution of dark matter, that invisible stuff that makes up most of the universe's mass, could play a role in both the formation of voids and the motion of galaxies towards the Great Attractor.
So dark matter could be the invisible thread that ties these mysteries together, kind of like a cosmic web.
It's a possibility, and it's something that researchers are actively investigating. By mapping the distribution of dark matter, we might gain a better understanding of the large-scale structure of the universe and how these seemingly separate phenomena are connected.
That's really fascinating. It's like we're starting to see the universe not as a collection of isolated objects, but as this intricate, interconnected system.
Exactly. And the more we learn about these connections, the closer we get to understanding the fundamental laws that govern the universe and our place within it.
It's amazing to think about how much there is still to discover. It's both humbling and inspiring.
I couldn't agree more. The universe is full of surprises, and every new discovery opens up new avenues for exploration and understanding.
Well, on that note, I think we've covered a lot of ground in this part of our deep dive. We've explored the possibilities of advanced civilizations, delved into the mystery of vanishing stars, and even started to connect the dots between some of the universe's most baffling phenomena.
We've certainly had a lot to ponder.
Well, folks, we're back for the final part of our cosmic journey. It's been a wild ride, hasn't it? Exploring these mind-blowing mysteries out there in the vastness of space.
It really has. From those giant empty voids to stars that just blink out of existence, it's enough to make you question everything you thought you knew about the universe.
I know what you mean. It's kind of humbling, right? When you think about the sheer scale of it all and how much we still don't know, it can make you feel pretty small.
I get that. But I also find it incredibly inspiring. The fact that we can even contemplate these mysteries, that we can try to make sense of them. It speaks to the power of human curiosity and our drive to explore the unknown.
That's a good way to put it. Even if we never find all the answers, the journey itself is what matters. The constant questioning, the pushing of boundaries, that's what drives us forward.
Absolutely. Every new discovery, every unexpected observation, it forces us to expand our perspective, to think outside the box. It's like we're constantly refining our understanding of the universe, peeling back layer after layer.
Like a cosmic onion, with endless layers.
Exactly. And who knows what we'll find at the core. But one thing's for sure, the future of cosmology is filled with possibilities. What do you think? Where do you see the most exciting potential for breakthroughs in the coming years?
What for me, the study of dark matter and dark energy is at the top of the list.
Hmm?
These mysterious substances make up the vast majority of the universe, but we still have no clue what they are. Figuring out their nature could completely revolutionize our understanding of how the universe works.
No doubt about it. And then there's the search for extraterrestrial intelligence. We touched on it earlier with those vanishing stars. But the quest to find life beyond Earth is only getting more intense.
Right. With all the new telescopes and technologies coming online, we're finding more and more exoplanets, planets orbiting other stars.
Hmm.
It feels like it's only a matter of time before we stumble upon some kind of alien life.
I agree. The possibilities are truly mind-boggling. And even if we don't find definitive proof of aliens anytime soon, the search itself is valuable. It forces us to think about our place in the cosmos and the potential for other intelligent beings out there.
Well, I think it's safe to say we've given our listeners a lot to think about today. From cosmic voids to vanishing stars, we've covered some pretty mind-bending territory.
We certainly have. But as we always say, this is just the beginning. There are countless mysteries still waiting to be uncovered out there in the vast expanse of space.
So to all you space enthusiasts, keep looking up, keep asking questions, and never lose that sense of wonder. There's a whole universe out there waiting to be explored. And who knows what incredible discoveries await us.
Keep exploring, everyone.